This is section 3-6, and we are going to have a quiz on Friday, unless you want it earlier. Friday sounds good? 3-1 through 3-5. Well, I already have it. You can take it in advance. It's a quiz. Okay? So what we're going to do today is evaluate inverse trig functions. This is in the assignment. Simplify inverse trig functions. Find the limit of inverse trig functions. This is not easy. And derivatives of inverse trig functions. But what is an inverse trig function? It's an angle. Okay, Matt? What is an inverse trig function?
An angle.
It's an angle. That's all it is. So we're looking for an angle. Now, I want to look at the inverse sine. Oh, good, I can do this. And let's first look at the inverse. Let's first look at the sine function. Maybe this will help. I want to find the domain and the range. So, guys, if I look at, this is the inverse of the inverse function. I don't know how to say that. Okay, if I look at the sine function, I want to restrict the domain of this function so that my function is always increasing or always decreasing. This is a new approach to this. And there's the sine function. Okay, James, Matt, I need you to pay attention. Okay, so what is the domain that I want to restrict this for? So x is going to be between pi over 2 and negative pi over 2. And honestly, this is the way I think about it when I do the inverses. Now, its inverse is the reflection over y equals x. And I'm not sure I want to try and draw it. I can try to draw it. But it's going to look something like this. Something like that. Better off on my calculator. Okay, by the way, what was the range of my sine function? It's between 1 and negative 1. And because we're now talking about the inverse sine of x, which is a different function altogether, it's that new one I tried to draw, not particularly well, what happens to domain and range? Because they're inverses. They switch. So now, when I look at this one, x is going to be between 1 and negative 1, and the angles that you find, because remember, that's an angle, will always be between pi over 2 and negative pi over 2. Why do we restrict them? So I get if the inverse is a function. Okay, guys? So I want the inverse to be a function. So when you put this into your calculator with the inverse sine, you will only get numbers that end up being between negative pi over 2 and pi over 2. It's always going to happen that way. And I'll have to do some work if I want to answer in a different quadrant. But right now, it's always going to come up that way. Otherwise, I don't have a function. So when you come up and you evaluate inverse trig functions, your answer for your angles must always be between pi over 2 and minus pi over 2. I don't know if this makes any more sense attacking it from this direction than it does the other way. The other way, I would just say that these angles would be here. But if I look at the fact that these are switched, that helps me. So when I look at my original function, like the cosine, then we'll look at the inverse cosine. Well, the cosine function looks like this. And I want my function to always be increasing or always decreasing. And I don't want to go from minus pi over 2 to pi over 2 because this does not pass the horizontal line test. You see what I'm saying? So I'm going to restrict this differently. So it's going to be restricted this way. Sorry, I don't want to say keep the curve. So if I look at this, the x, now this is y equals the cosine of x. So what's x going to be between? My angles I'm going to restrict between 0 and pi. What will the outputs be between? 1 and negative 1. So when I do my inverse cosine, the domain and the range will switch. So now x is going to be, the inputs that you put in here have to be between 1 and -1, and the outputs are going to be between 0 and pi. So you're going to be in the second quadrant, not the fourth. Questions? Does does it make sense? But I'm doing this quickly. I like this way, doing it better than I've done it in the past.
Which area to look at? You just want to choose an area where it's always increasing and
right. I could have picked this part of the curve if I preferred.
What's the
as opposed to this, that's just what everybody's decided to do, by convention. That's what the math community decided to do. We'll take this section where it's always increasing or decreasing. Could have taken, by the way, this section. That works too. But they wanted to be centered close to 0. So what about the tangent function? So when you get your answers out on cosine, you're going to have answers in the first or second quadrant. So what about y equals the tangent of x? Well, I want this to always be increasing or decreasing. This one's a little easier. Where are we going to restrict this? -pi/2 and pi/2. So the inverse tangent is going to be just like the sine. Okay, so let's get my domain. X is going to be between pi/2 and -pi/2. Can't include those because they're vertical asymptotes there. And what's true about the y values? Yeah, it's anything, right? So then when I go to the inverse tangent function, what happens to your domain and range then? They switch. So x is going to be anything between infinity and -infinity. And the y's are going to be between pi/2 and -pi/2. And I think that might be the easiest way to remember domain and range. Okay, do you remember your inverse trig a little bit? A little bit. Okay, so let's do some problems there on the back side. No, we did this last year. The parametrics we didn't do. And I'm sorry, I'm missing a parentheses. I think it's fixed on yours, but it's not on mine. Okay. I didn't use equation editor, so I did the arc sign instead, because I could just type that in. I prefer to look at it this way. Okay, Matt. This is what? It's an angle. You got to keep thinking inverse trig is an angle. It's called theta. So what this means is the sine of my angle is 1/3. Well, now we're just going to use a little geometry and Pythagorean theorem and find the tangent. Okay, so there's my angle. There's theta. This is 1. This is 3. Then I know that side, right? By Pythagorean theorem. So it's going to be the square root of the hypotenuse squared minus the side squared. So it's the square root of 8. Some of you on math team did C, I think it was C, saw some of that yesterday. Because I do them all. How'd you do? How'd you do? Oh. Oh, that's too bad. Okay, well, let's finish this problem. That won't happen again, likely. The tangent of my angle, you guys, what's the tangent of my angle now? The picture. Opposite over adjacent, so it's 1 over the square root of 8. Well, this is the tangent of an angle, right? That's theta. Well, then let's rewrite that. The sine of theta is 1/3. So here's theta. That's 1. That's 3 by Pythagorean theorem. What's this going to be? The square root of? Because I want to find the tangent now of my angle. What's the tangent of my angle? Guess what? We're going to do more of these. But we're not going to do numbers. We're going to do letters. Is that okay?
I can do letters. Numbers screw me out.
Okay. Why am I doing this? Because I want to get to the derivative of the inverse trig functions. Matt, what does this mean? This is an angle. Write that differently. What is that? What would that look like? Means the sine of, and I would like to write x as a ratio. It's x over what? 1. Okay, so I'm going to draw my triangle. That's the right triangle. That's that one. There we go.
Oh, this is how you get the...
Yeah, these are identities. So the sine of this angle is x over 1. What's this side going to be then? Square root of 1 minus x squared. But now I want the cosine of this. What's the cosine of my angle? Square root of 1 minus x squared over what? So instead of memorizing these identities, I just draw the pictures and work it out every time. Must have been the fancy computer drawing of the triangle that made you get it. That was the only difference. Okay, ready to try the next one? Cosine of the arctangent of x, because we're going to run into these. Okay. Okay, what's this one going to be? Jeremy, can you rewrite this? I don't like the way it's written. This is an angle. X. And what's that fraction? X over 1. So this is x, then this is 1, and this is 1 plus x squared. So what's the cosine now of my angle? 1 over square root of 1 plus x squared. What's the secant of my angle? Remember what a secant is? It's the reciprocal of that. Remember secants? Because we're going to run into it. Okay. Now this one's a little trickier, and I don't know how you would do it. I just know how I like to do it. I want the limit of the inverse tangent. You could just put in the 2 from the right side. I prefer to go back to the tangent of theta, but if I put in 2 from the right side, it's the arctangent, and this is going to be 2 from the right side is positive infinity or negative. It's 1 divided by 0, so it's either going to be positive infinity or negative, but it's coming in from the right side. So it's positive infinity, which means that the tangent of my angle is positive infinity. And remember that my values have to be between pi over 2 and minus pi over 2. So if I look at my picture just of my tangent function, this is how I do it. You can do it differently. I'll show you another way. What's the answer to that? What's the limiting value? Okay, because remember, I'm looking for the angle. It's pi over 2. Had it been negative infinity, had I come in from the left, it would have been negative pi over 2. Mrs. Hirschman remembers what the inverse tangent looks like. I never remember that. Never is probably too strong a word, but and it looks like this. Okay, so this is pi over 2. Minus pi over 2. Right. It's a reflection over y equals x, which ends up being yes. So if you want this to go off to infinity, you got to be getting close to pi over 2. I prefer to think of it that way. It's just the way I think. But it doesn't matter to me. I draw pictures. So you have some limits. We don't have work time today. So what about the derivative of the inverse sine? Now you might remember it. You might not. I don't think it's up in here. I don't think anybody did it. Oh yeah, it is. It's right up there. What if you're on the exam and you forget? Unfortunately, you won't be taking the exam. If you are taking my room, I have to have all the science stuff. Okay, I'm going to instead solve for x in terms of y. So what's x equal to? Okay, why did we do implicit differentiation? Because now I need it. Let's take the derivative with respect to x. Don't put dy dx because that's not right. It's d dx. Okay, David, what's the derivative of the left side?
What?
And what's the derivative of the right side? Times, chain rule. Okay, why did I do all that triangle stuff? If you solve for dy dx, I get 1 divided by the cosine of y. And I'm not going to leave my answer like that. I'm not going to accept that answer. And it won't be accepted on the exam because it's not done. I want x's in there, and I want to know, I want it simplified. Some of you might say, well, y is inverse sine, so it's the cosine of inverse sine of x. I don't want to even do that. So we just did all these triangle things. If y is inverse sine of x, then that means the sine of my angle is equal to x. So I'm going to draw my triangle. You might have already, you should beat me to it. Okay, so this is y, and it says the sine is x over 1. What's this? What's this side? 1 minus x squared. So now if I take the cosine of this, it's 1 over the cosine of y, which is square root of 1 minus x squared over 1. So there's your derivative of the inverse sine function. Yes? You do, but what if you're in the exam and you forget? You can do it. You have the tools to do it. I solved for x in terms of y, and I took the derivative, and then I used the chain rule right here. And then I did 1 over the cosine of y. Well, y is the inverse sine of x. So I want to do the cosine of inverse sine of x. If I go back a number of slides, and you go back and look on your paper on the other side, you've got that, right? It's there someplace. It's 1 over this. I'll make that mathematically correct there. There's a good reason why you should never shortcut something like I just did, because then you get confused. So I would like you to try the derivative of the inverse cosine. And the next one is the derivative of the inverse tangent. So why don't you guys try those? Oh, you want to do this one? So y prime. I just put in the numerator. 1 over, okay, is negative 1 arctan to the negative 2 times the derivative of the inside function, which is 1 over 1 plus x squared. Whoops, I forgot my x. If you do the quotient rule, that also works. Because, remembering the quotient rule, it is, okay, you guys, arctangent of x times the derivative of the numerator, which is 0, minus, then it's the numerator times the derivative of that, which is 1 over 1 plus x squared, all over the square of the denominator. Arctangent squared. And I hope you can see they're the same things. What'd you miss? That's 0. So it's negative 1 over 1 plus x squared all over arctangent of x. But if I want to simplify that, this is in the denominator, that's in the denominator. But let me prove to you why they're both going to be in the denominator. This is 1 plus x squared, and this is 1 plus x squared. So this gives you negative 1, guys, over arctangent squared, which is 1 plus x squared. Now, that's the same as this piece right here. The next one's a little trickier. You have multiple chain roll. Try that one. What rule do you have to use to do this one? Product. Yes. Guys, they're way too much fun on my class. A little too much. How did this get over there? There. Try that one.
Remember having Jeff run with us?
Mm-hmm. You see? Yeah.
Wait, you got Mr. Coach Bradley.